Hi, in this video we will discuss a TI design demo for the C6747 voice processing. The demo consists of an OMAP L137 floating point starter kit with a prototyping adapter connected on top of the board. The microphone inputs are taken from a circular microphone board or a CMB consisting of 8 microphones in a circular geometry. The captured audio is sent to the OMAP L137 for voice processing. The processed audio is then output to headphones. The left side of the headphones will contain the processed audio and the right side the unprocessed audio. A PC running Code Composer Studio is used to control the OMAP L137 floating point starter kit in order to load the programs and for debugging purposes. Alternatively, the audio can be piped to the PC via an audio line out cable and be analyzed using software such as Audacity. The voice processing algorithms that are running on the C6747, which is on the OMAP L137 starter kit, are the algorithms beamforming, adaptive spectral noise reduction, multi-source selection, dynamic range compression. The audio is sent from the CMB to the EVM via the MAC-ASP port. In order to test the demo, someone can stand in front of the circular microphone board and speak to it from a certain angle and simultaneously have a noise source from a different angle. This setup can be moved around as desired in order to test the voice processing capabilities of the demo. In order to run the demo, you would need a PC, an OMAP L137 starter kit, a prototyping board, a circular microphone board, some jumper wires, a pair of headphones, and some USB cables. Begin by connecting the prototyping board to the OMAP L137 starter kit. The two boards can be connected together by aligning the connectors and pushing the two boards together. Next, using the jumper wires, connect the CMB to the prototyping board. The wire mapping details are provided here and also in the TI design guide. Ensure that the pins are connected correctly, as it's easy to get confused between pin numbering as they are closely spaced. Next, connect a USB cable to the JTAG connector on the OMAP L137 starter kit. Connect the headphones to the headphone out jack on the starter kit. Finally, connect the power brick to the starter kit. This video assumes that Code Composer Studio has already been installed in the system and a target configuration for the OMAP L137 starter kit has already been created. Launch CCS and launch the target configuration for the OMAP L137 starter kit. Connect to the core and load the pre-built binary from the Processor SDK RTOS package for the L137. Links to download the SDK are provided at the end of this video. Load the .out file from the path specified here. Once the .out file has been loaded, hit the Resume button. At this point, there will be printouts on the console indicating that the circular microphone board has been initialized and the audio processing demo is running. You will notice that a blue LED on the CMB will also illuminate, indicating that a successful initialization of the CMB has occurred. At this point, the audio that's captured by the CMB is sent to the L137 board and the process audio is then piped to the headphones. The left side will have the processed audio and the right side will have the unprocessed audio. You can rub your fingers over each microphone to see which one is being piped to which headphone. Please be careful as you rub your finger over each microphone, as the volume levels can be high. Optionally, an external USB sound card can be connected to the headphone jack in order to pipe the audio to a PC. This will provide a mechanism to analyze the audio in software such as Audacity or Adobe Audition. To do this, you would connect the line in to the external USB sound card and the other end to the headphone out of the L137 starter kit. Connect the USB sound card via a USB cable to the PC. The external sound card provides a mechanism for the user to output and analyze the quality of the audio processing. In this example, we are using Audacity to analyze the audio. Ensure that the correct sound source is selected in Audacity. In order to test this demo, go ahead and start the recording on Audacity. Simultaneously, play some white noise in the background and speak into the microphone array.
Testing 1, 2. Testing 1, 2.
Zoom into the waveforms in order to see the noise suppression levels. The audio track can also be split into left and right channels in order to analyze each side separately.
Testing 1, 2. Testing 1.
Please refer to the TI design and the reference guide for additional details on the demonstration that is illustrated by this video. For more information on the resources discussed in this video, see the links here. For support questions, please post on Texas Instruments E2E forum for the C6747. This concludes this demonstration video. Thank you for watching.